Already we have seen 7 construction rules. Today, let us see the 8th and 9th rule. Then we will see some problems on root locus construction. 8th rule says the intersection of a root locus with imaginary axis can be determined using Root criterion. For example, I'm having a third order system. We know that one root locus branch go to infinity like this. Another two will go to infinity, one at an angle 60 degree like this. Another one will go to infinity minus 60 degree like this. But the point of intersection at imaginary axis we have to find, that is j omega we have to find. This j omega tells this will occur when k equal to k max, the maximum value of k at which it will exhibit sustained oscillation. And after that, the system becomes unstable because the poles moves to the right hands, RHS. Till then, it was in the left hand side. So when k equal to k max, the system transfers from stable state to unstable state. That is in the marginally stable state when k equal to k max. That we can found that omega by using Root criterion. By using Root criterion, we can find. While using Root criterion, how to find that omega? We have to make s power 1 row. Only one element will be there. We have to make it equal to 0. Then, on making the s power 1 row equal to 0, we can find the value of k max. K max. After finding k max, we have to substitute that k max in the s square row. Here, two elements will be there. It will be function of let us say ak. Therefore, you will get as square plus k equal to 0. You will get, from that you can find s equal to k by a plus or minus j square root of k by a. You will get like that. We can find omega. S equal to what? S equal to j omega. Therefore, omega equal to square root of omega equal to square root of k by a. That value is omega. This point of intersection is square root of k by a. That is 8th rule. 9th rule. What 9th rule says? 9th rule is to find the value of k at a particular point on the root locus. Suppose I want to design a control system whose zeta must be 0.7. We know that suppose zeta equal to 0.7 means theta equal to cos inverse of 0.7. That is equal to 45.5 degree. So I have to draw a line at 45.5 degree. 45.5 degree line. This is called constant zeta line. Constant zeta line. That zeta equal to 0.7. Zeta equal to 0.7. Now it intersects at A with root locus. At this point, what is the value of k? If you know the value of k, if you substitute that value of k as controller gain, then the system will exhibit with zeta equal to 0.7. If you substitute that value of k here, the system will have a damping factor of 0.7. How to find k at A? For that, what are the poles? Poles are P1, P2, and P3. So from A, draw lines to P1, P2, and P3. Measure the length. The length be AP1, AP2, AP3. These are the length measured from A to A is the desired location of pole. Divided by, suppose we are having 1, 0 here. Let it be Z1. So from A to Z1 also we have to draw a line. Let it be A Z1. Divide by A Z1. This is the value of k. This is the value of K. Product of, that is K equal to product of phasor lengths from A to open loop poles. Product of phasor lengths from A to open loop zeros. Here, in this formula, S0 is taken as the point at which we want to locate the poles. We want to locate the poles. So we can find the gain K at the desired location. If you put K equal to this value in a closed loop system, it will exhibit the desired zeta. Let us see one problem on root locus. Sketch the root locus of a feedback system whose open loop transfer function is given by S K upon S multiplied by S plus 2 multiplied by S plus 3. So what are the poles? It is a third order system. Therefore, the poles are 0, minus 2, minus 3. That is n equal to 3. Zeros nil. Therefore, m equal to 0. Therefore, number of branches, number of root locus branches, number of root locus branches equal to 3. How many will end at infinity? All 3 will end at infinity because n minus m branches will end at infinity. M equal to 0. Therefore, all 3 will end at infinity. Therefore, they will go to infinity at an angle phi a, that is equal to plus or minus 2q plus 1 multiplied by 180 divided by n minus m, that is 3. When q equal to 0, 1, 2. If you substitute 0, you will get 180 divided by 3 equal to 60 degree. Then 180 degree and 300 degree. 300 degree. So when q equal to 2, you will get 300 degree. This is the angle of asymptote at which the root locus branches go to infinity. The asymptotes are meeting at centroid sigma a, that is equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m. That is equal to sum of real parts of poles equal to what? Minus 2 minus 3. Minus 0 divided by 3. That is minus 5 by 3. 5 by 3. 1.7. That is 1.7 minus 1.7. 6.7. That is 6.6 or 6.67 or 1 point simply says 1.7. In the graph sheet, we cannot mark 1.667. That's why let us take the single decimal place 1.7. They are meeting at 1.7. Now let us draw the root locus. For that, we have to take the S-plane. Take S-plane. Sigma j omega S-plane. So minus 1, minus 2, minus 3, minus 4, 0, j, 2j, minus j, minus 2j. Here, what are the poles? The one pole at the origin, another pole at minus 2, another pole at minus 3. Any point between minus 2 and 0 are all the 3 poles are starting points of root locus. Between minus 2 and 0 is part of root locus because to its right odd number of poles and zeros. Therefore, both are starting point. Definitely, there will be a breakaway point. If you select any point between minus 2 and minus 3, it is not part of root locus because to its right even number of poles and zeros. If you select any point after minus 3, it is part of root locus because to its right odd number of poles and zeros up to minus infinity, the root locus branch goes. So minus 1.7 is sigma a. So let us draw that asymptotes 1.7. So that is 1.7 here. at an angle 60 degree, it goes to infinity. And this is also goes to infinity at minus 60 degree. That is 300 degree, 180 degree. So in 180 degree, this root locus and asymptotes one over the other. This is asymptote. This is asymptote. This is also asymptote. Asymptote. Now, this is sigma A. Sigma A. Sigma A is equal to minus 1.7. Now we have to find the breakaway point. For that, we have to find dk by ds equal to 0. What is k? K equal to minus 1 by g of s. That is equal to minus s multiplied by s plus 2 multiplied by s plus 3. That is equal to minus s square plus 5s plus 6. That is equal to minus s cube plus 5s square plus 6s. Therefore, dk by ds equal to 0. That is minus minus of 3s square plus 10s plus 6 equal to 0. The roots are the roots of this are minus 2.5 and minus 0.8. Minus 2.5 and minus 0.8 are the roots of this dk by ds equal to 0. So, two roots we are getting minus 2.5, but minus 2.5 is not on the root locus because between minus 2 and minus 3, no root locus. That's why this is not on the root locus. But this is on the root locus. Therefore, 0.8 is the breakaway point. 0.8 is the breakaway point. This is breakaway point. It come out like this. This is the point minus 0.8 is breakaway point. Breakaway point. So now we have to find the point at which it will go parallel to this asymptote. So it will turn and go parallel to this asymptote, but at what point it meets the j omega axis, that we have to find by using the rule number 8. So we have to form the Root array. Root array. We have to form Root array. For that, we have to write this is the characteristic polynomial. What is characteristic polynomial? 1 plus the characteristic polynomial is 1 plus g of s equal to 0. That is 1 plus k upon s multiplied by s plus 2, s plus 3 equal to 0. If you simplify this, what you will get is s square cube plus 5s square plus 6s plus k equal to 0. If you simplify, take LCM and equate 0, you will get s cube plus 5s square plus 6s. This is the characteristic polynomial. This is the characteristic polynomial. For that, we have to use the Root array. Therefore, s cube, s square, s cube, s square, we have to write 1, 5, 6, k. S power 1, then s power 1. That is 30 minus k divided by 5. S power 0 is k. How to find the k max? We have to equate s power 1 rho equal to 0. If you equate s power 1 rho equal to 0, k max equal to 30. You will get. So substitute that 30 here. You will get 5s square plus 30 equal to 0, or s square equal to minus 6, or s equal to plus or minus root 6. That is j root 6. J root 6, that is equal to minus 2.4. Minus 2.4. So it cuts the root locus at minus 2.4. This is minus 2j. Therefore, 2.4 will be here. 2.4 will be here. Here. Therefore, the root locus branch passed through that. We have to draw a line like this. It goes parallel to the asymptote. That's all. This goes to up to infinity. This also goes up to infinity. This is here. Suppose I want to find the value of k for zeta value of 0.7. Zeta equal to 0.7. I want to find the value of k. For that, I will draw a line. Draw a line that is constant zeta line. Constant zeta line. It's zeta equal to 0.7. The angle made with the negative real axis is 45.5 degree, because cos inverse of 0.7 equal to 45.5 degree. So this intersect the root locus at A. So we have to find the length from A to all poles. All poles. This is P1. This is P2. This is P3. All poles. No zeros. That's why only poles. The length equal to AP1. Length equal to AP1, AP2, AP3. If you know all these lengths, we can find the value of k. You can measure. Suppose this is equal to 1 centimeter. This is equal to 1 centimeter. Means you can measure the length by using your scale, and you can substitute. You can find the value of k. Or else you can analytically find AP1. What is AP1 equal to modulus of A minus P1. A minus P1. A minus P1. A minus P1 equal to what? A equal to, let us assume that let us assume A equal to -1 plus J. Just I'm assuming. Here we can find what is that? A 0.8. This is not 1, minus 0.8. So we can find 0.8 J1. A equal to in this graph, from graph A equal to 0.8 plus J1. So what is AP1 length? Analytically we can find modulus of 0.8 plus J minus P1 is 0. Therefore, modulus of 0.8 plus J. You can call the function polar to rectangle of 0.8 plus J. 0.8 plus J you can call, so that you can find the magnitude, or you can find this way, square root of 0.8 square plus 1 square. That way also you can find. So substitute, let it be AP1. AP2 equal to what? AP2 equal to modulus of 0.8 plus J1 minus, what is P2? P2 is at -1. Therefore, the magnitude equal to +1 minus 0.8. This is minus A equal to minus 0.8. This is A equal to minus 0.8. Minus 0.8, because it is in the negative side. This coordinate is minus 0.8 plus J. Therefore, it is equal to 0.2 plus J. So therefore, AP2 equal to, AP2 equal to, you can call polar coordinate of 0.2 minus 0.2 comma plus 0.2 comma 1. You can pass and you will get the value from the calci, or you can calculate this way, square root of 0.2 square plus 1 square. This way also you can find AP3 equal to what? AP3 equal to minus 0.8 plus j minus of minus. Next pole is at 3 minus 3. Therefore, what you will get is 2.2 plus 2.2 plus j. Therefore, AP3, the length AP3 equal to, you can call polar coordinate of 2.2 comma 1, or you can calculate square root of 2.2 square plus 1 square. This way also you can find. So now you got the no zeros. Therefore, denominator is 1. Therefore, K for 0.7 equal to AP1 multiplied by AP2 multiplied by AP3 divided by 1. This way we can find the value of K for zeta equal to 0.7. This way we can use the root locus to find the desired location of, find the value of K for desired location of poles. So the desired location of pole is at A, because at A it gives zeta equal to 0.7. That's all.